regulators. We regulate any stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep.
Regulators! Mount up!
Oh, hello, we are developers. Hey, yes, thank you. It is nearly lunchtime. And we're in the middle of the second day as well. So, yeah, we need a little bit more energy. That's what I thought. I thought we need a little bit more energy. Oh, I'm kind of losing my voice. This is like my third talk in a row. And I'm like, ah. So I'm really, really sorry. I will try and speak up. And I hope that you can all hear me. I've been trying to warm it up all morning, but there's no tea in the venue, so it's really hard for me. I'm Ruth. Hello. Pleased to meet you all. This is the part of the talk where I tell you what I do, the job I have, all the credentials I have, and why I get to be up here talking to you about web stuff. I don't do that. I show you. So if you'd let me, I'd really like to show you. I'm here today to talk to you about how to be a web AV artist. And I'll be honest with you, I struggle with the practicality of this talk, right? I mean, who here even knows what a web AV artist is? And I'm going to talk to you about things like audio APIs and MIDI APIs. And who tomorrow, that is great, isn't it? That's really helping with my voice. And who tomorrow is going to go back and build some websites using the MIDI API? Right? So I'm thinking there's no practical advice for me to give you to take away. Did anybody see this Venn diagram that was going around the internet about 6 months ago? So on one side of this Venn diagram, it talks about what people talk about in conference talks. And on the other side of the Venn diagram, it talks about what developers want to hear in conference talks. So I have taken this very literally to make sure I give you a very useful talk today. So I've made two lists, right? I've got two lists based on this Venn diagram. On one side of the list is things that I have to avoid in this talk. And on the other side is things that I have to include. And as long as I include these things, I'm going to give you a very useful talk. So things I have to avoid, should be easy, analytics, operational excellence, chat ops, orchestration. Simple, right? Things I have to include, duct tape, workarounds, bike shedding, and coffee. OK, so I wrote a little function. And the function, every single time I say one of these things, is going to give me a smiley face if it's something I need to include, and a sad face if it's something that I shouldn't include, OK? So now I've got my talk anxiety out of the way, I can begin. What is a web AV artist? What is an AV artist? AV stands for audio visual. Right? So it's taking audio and making visuals with that audio. It's not so much of the making audio yourself, although we will touch a little bit on it. It is just taking the audio and making really nice visuals. Another word for this is VJ. So I'm going to talk you through how to do this a little bit in a browser, because we now have the technologies. Let me just, it's going to be loud. Who remembers this?
Winner. It really whips the llama's ass.
Yes, I've got some nods. This is great. OK. For those of you that don't remember this is the MP3 player of choice from back in the day. It's very, very lightweight when we actually used to play MP3s instead of streaming them. But this wasn't the best bit about this music player. No. The best bit about this music player was this. It had a visualization engine. Right? So when you were playing your music, you could whip up this visualization engine, and all the visuals would go in time to the music. And it was great. You could sit it, and you could just watch it for hours. I think this is probably the biggest influence of VJs of my generation. So this is basically what we're going to try and do. We're going to try and do something similar in a browser. The first thing that we need to do this is audio. Now, this is pretty straightforward, because we have a web audio API. And there are 4 main ways with the Web Audio API to get audio in our browser. The first way is we can make it. OK, good. We can see the code. That's great. We can make it. So we can create an oscillator. Now, this is going to create a sound wave. So you can do that 4 default ways. You've got like a sine wave, a square wave, a triangle wave, or a sawtooth wave. There is a new node, actually. There's a create periodic wave, where you can actually create your own wave to create your sound. The 3 other ways, you just use files. So you can take it directly from the DOM. So if you've got an audio element or a video element sitting in your HTML, you can grab the source of those elements and pipe that into the audio API. The third way is to stream it. So this is most commonly done from your microphone or your camera on your device. So you take a stream, and then you can stream the audio from that stream into the audio API. The fourth way is to buffer it using file data. So you go and get yourself a sound file, and then you have to put it into a sort of container that sits in the audio API, which will decode that data for you. And then you can use that sound data as and when you like. Here I'm using the fetch API to go and get me that sound file. So they're the four main ways to go and get sound. And here's a couple of examples. So this is using a sound file. And we're just getting that sound. And then the other way, which is my preferred way, is to actually pipe it in through the microphone. So this is picking up on my microphone. I'm streaming that into the audio API. Now, the biggest thing that we need, now that we've got sound, the biggest thing that we need to make visuals is to analyze sound. Oh. I wasn't allowed to mention analytics. But it's okay. There's just one down. We've got the whole rest of the talk to go. It'll be fine. This is going to be a useful talk, I promise. So yes, we need to analyze sound. Again, we can use the audio API to do this. It has a specific analyzer node, which is great. This gives us time data and frequency data. What I'm interested in is frequency data. And frequency data is sounds from low to high. So it's like the pitch of the sound. And what you do when you instigate the analyzer node with the audio API, as per code here, is you get back an array of velocities of frequencies. Okay? I'll talk you through it. It's okay. It's easier than it sounds. So you instigate an array, and you can make that array as big or as small as you like. The bigger, the more numbers you get, basically. And each item in this array represents a frequency. So right at the bottom, we've got 0, and right at the top, we've got 20,000 hertz. It's quite high. And then what you get back at any given time is the volume of that frequency of the sound that you're analyzing. And it's just a number. So all we're doing is just working with numbers. We're just working with data. And that way, it just becomes quite simple. This visualization here is just taking that number, and it's just a bunch of I elements in the DOM, and it's just taking the number at any point in that array. So I've got one I element for every item of the array, and I'm just making them higher and smaller depending on the number that I'm getting fed back. It's really, really simple. I'm just looping over them and changing the height. So we can now all make visuals in a browser, and I'm done, and I can go, because my voice is really, OK, cool. It's fine. I'll take you through some better ways. So I thought, this is actually really simple, and it would be really, really nice if I could do some more experiments and push this as far as I can, basically. What else can I do in the DOM? And everybody knows when you start experiments that you need some inspiration. So this is my first inspiration. This is Bridget Riley. I actually discovered her at Scotland JS last year. I went to the art gallery, and I went into one of her galleries, and she just has these massive paintings of shapes. I was like, this is cool. I want to visualize her shapes. So I did that simply just with DOM elements. So this is one. I've got a couple of examples, and this is one of them. This is just some DOMs being positioned with Flexbox, and I'm just changing the width of the Flexbox based on the data that I'm getting back. Another one is some triangles. So this is done with the border hack for triangles. And we're just changing the opacity, again, based on those numbers. So it's quite simple. And already we've kind of got some visuals. And then I started playing around with lots of the CSS things that we now have. So transforms is kind of cool. When you're making visuals, you might want to do something symmetrical. So you might want to rotate, reflect, whatever it is that you've already created. So I wrote a function which takes whatever is in the DOM and then repeats it and rotates and reflects it. And we get things like this, which is also quite nice. You then think, because you're at this stage, can we just drop a GIF in? You can just drop a GIF in. You're like, this is cool. My Little Pony GIFs, repeated and reflected. Great visuals. Some other really nice CSS things are blend modes and filters, because I wanted to play with these. For those of you that haven't really played with these, blend modes are sort of like those Photoshop layer modes that you get. So you can see things below in the DOM in different ways, so lightening and darkening as you go. Filters are your more sort of photo inverting, desaturating, making them black and white, that kind of thing. So blends work really, really well with visuals. I was at JSConf EU last weekend, and I did their after party. I actually did the visuals for their after party. So I was creating some visuals for that. This is using blend modes on SVGs. So you can actually use these blend modes on SVGs, and you can see all the layers going together. Filters are really, really good for video, by the way. So your invert mode filter works on video. You may not know it if you don't, but it is very nice. You can just play a little video, you can have it go in time to the music, and then you can just make it invert as well to the sound. A top tip if you want to do visuals. But the one real key thing that I discovered when I was doing CSS stuff, a really nice new one, is custom properties. So this is a really interesting one. We use CSS in our JavaScript quite a lot, but we haven't ever really used JavaScript in our CSS. And this changes the game just a little bit. For those of you that haven't, I'm sure we've come across custom properties, but for those of you that are unaware, anybody that's used a CSS preprocessor, so SAS or less or anything like that, this is a basic case variable. It's not exactly the same, but it's a variable sort of in spec. And we're declaring it here, so you can see in the root level element, we're doing a dash dash, whatever we want to call it. I'm calling it level because what I'm doing is I'm actually going to change that on the data which I'm grabbing from the analyzer. And I'll take you through it. So at the moment, my level is 1. And then I'm using that on my eye properties in the CSS. So there I'm declaring the var keyword, and I'm changing the width and the height based on that level. And then in my JavaScript, I'm able to pipe the data that I've got from the analyzer node back into my CSS by calling that level custom property. And I can do that with the document element.style.set property. Yeah, you can see it there. And so what it's doing is it's changing that value in real time. This is JavaScript in your CSS, which is kind of crazy. I wouldn't recommend doing this all the time, but it does mean that you can add some really, really nice effects. The thing is, I tried all these things. So this is an example of all of them. We've got blend modes, we've got some custom properties, we've got some transforms. You might notice it's a little bit janky, and actually it doesn't really like operating very well. Oh, wasn't allowed to talk about operational excellence. You can see where this is going, can't you? It's fine. Yeah, so it wasn't really playing very, very nicely. This is my friend Ben. I was talking to Ben. This is a really, really good tip. They're not just good for rubber duckying, friends. They're actually good for talking to when you're trying to engineer something, because they have different perspectives on what you should be doing. So I was chatting to Ben. Not allowed to talk about chatting either. Chat ops. I've only got one to go. This is not going to be a useful talk. I was talking to Ben, and we were talking about performance within my application. I was doing an interactive installation, and I was using a lot of the same technology. And he suggested using d3.js. Now, I'm of the sort of factory where I don't really include a library unless I really have to, but he was making a good case. D3 is a data visualization library, so you think of pie charts and bar charts and things like that. But if you think about it, I am visualizing data. I'm visualizing audio data. It works really, really well with data, and it does come with a lot of math stuff, and I'm doing a lot of maths essentially, especially with some of the harder visualizations. So for that, it was very good. It also plays with the DOM very nicely, and that was some of the performance troubles that I was having, was all these elements in the DOM wasn't really working. And also, I can use SVGs very easily, and they just render better. So yeah, thus started my next set of experiments. So my inspiration for this set of experiments was this great book. It's called Super Graphic by Tim Leung. And it basically charts data from comics and graphic novels. It's really nice just to flick through. So using this as my inspiration and using D3, we started making basically really quite cool graphics. And these are all just going in time with my voice. So if I stop talking, oh, there's still too much noise around, but you get the idea. This one's a nice little sunburst chart. We can do some sort of concentric circle things going on. This is the one that I did at the beginning of the talk. This is sort of reimagining the spectrum. So we're going from low noises to high noises. As is this one. This one's a kind of a nice flower thing going on. And it was really, really good fun, because these are just SVGs, and we're just doing the same thing. We're just attaching that audio data and just changing parameters for them. The data itself, I just want to readdress this. This is the last time you'll use your brain before lunch, I promise. When we get this array back, we have this array of frequency volumes, basically. But this isn't really how sound works, and I'll try and explain it. We've got an array here from 0 hertz to 20,000 hertz, so that's 20 kilohertz. That's pretty high, and sure, we can hear it, but we don't in everyday life. This is a keyboard. It's the same as a piano. This is where it sits on those sound levels. It runs from about 0 hertz to about 6,000. So there's a lot of data we're getting, which we're probably not going to use. Now, bear in mind, I'm not trying to accurately analyze notes. I don't really care too much what the actual note frequencies are of the music, but I do want to be more accurate about analyzing the music that we're hearing. So I don't really care about the upper realm of data. I don't really need it. And this is important when I want to do things like low frequency detection, mid frequency detection, and high frequency detection, because I don't want to do high frequency detection at the top end of that spectrum, because there's not going to be a lot there. I want to do it at the top end of the 6,000 hertz section. The other thing to notice about notes is this. So this is a keyboard. All the notes that are colored are the note A. So you usually have an octave, and notes are depicted from A to G. And so the A's there are obviously like lower and higher, but they harmoniously sit together. This is why you have octaves. The middle one here, this orange one, this runs at 440 hertz. The A below it, the purple one, runs at 220 hertz. That's a gap of 220, because we can all do maths. That was super easy. The one above it, though, runs at 880 hertz. That's a gap of 440. So the gap's doubled. They're not equal gaps. When we analyze the audio API, we are getting equal gaps of frequencies. We don't want to have equal gaps. We want it to be more representative of this. So what we need to do is we need to slice that data off we don't need and spread it out. So we can do that. It took me about a month to write this function. This function is open source, and I will properly open source it in its own GitHub repo. I'm not going to talk you through the code right now. That's a whole talk unto itself. But basically, that's what it's doing. It's taking the array and creating a new one, which is better analyzation of the sound. This is illustrated by this, which is before I've run the function. As you can see on the right, there's more activity. This is because where the activity is in that analyzation. After we run the function, it's just more spread out. You know, we get a better realm of that data, which might not make a better visualization in this case, but for all the rest of the analyzation that I want to do, it's better. Visuals, right, okay, we've got visuals, that's important. Things that I haven't mentioned, I sort of touched on video and imagery. I do use a lot of them in my visuals, but they're really easy. You just stick a video or an image tag into your DOM, and you can use them. 3D, I have just started playing around with 3D. I played around with Three.js last year, and I found request animation frame was just too heavy. I've just started working with A-frame, which obviously uses Three.js, but it just works better with how I'm working with the DOM, and I actually recommend it. So we've got these visuals, but you go and play a gig with your software, and you're projecting your visuals in this gig, and somebody, a band or a DJ, they've got this equipment that they're playing, and you're sort of sitting there with a laptop and a keyboard. You want a better way to control those visuals. And there are better ways. Sometimes I do use the keyboard and I use key events. I've tried the Gamepad API, which is fun, and controlling visuals with Gamepad is fun, but it is a little bit flaky, and you need libraries to support it. MIDI. MIDI is amazingly good for this. MIDI is not sound, by the way. It's not that 80s bleepy sound that a lot of people think it is when you talk about MIDI. MIDI is a data protocol. There was a rise of electronic instruments in the 70s. And industry experts and music manufacturers got together, and they said, wouldn't it be lovely if all these electronic instruments spoke to each other? So we'll just create a digital protocol for that, an electronic protocol. And they did, and that's how MIDI came about. The first specs came out in 1983, I think. They've since been revised. It's a bit like the change between HTML4 and HTML5. They're revising, they're getting better every time. This is a MIDI instrument. So this sends MIDI data. If I plug this into my computer, it's going to send MIDI data to me. It has onboard audio. I'm sure that we've all seen one. We've probably all even played one. It's a keyboard. So you play it, and it has audio. Like I said, it's MIDI enabled. A lot of instruments are. So when they actually talk to your computer, they can actually talk to each other and they can orchestrate with each other. I wasn't allowed to talk about orchestration. It's made this a really useless talk. I'm quite sad. Never mind, we're nearly at the end. It's fine. The difference between an instrument and this, which is a controller, which you might have seen, this doesn't have any onboard audio. But you still press the keys, you can still press the pads, and it will still send data. So if you run, so this is a launch pad, by the way, very common, quite reasonably affordable. You plug it in via USB, and you get data. If you run Web MIDI API in Chrome, this is like listening for the events that I press when I'm pressing MIDI instruments or MIDI controllers. And the kind of data you get back is just basically a small array of numbers. And it can be 2 or 3 values depending on what kind of, whether you've pressed a pad or whether you've turned a dial or something like that. So we can use this to control our visuals. So this is my MIDI controller. This is actually my hand. I've got quite a few. This is my handbag MIDI controller because it's small and it's light. This is a Minim. It actually works over Bluetooth. So sometimes it doesn't work. We're going to try it. Should we try it? And so what I can do is try and mix using my CC pad here from one visual into the other, which is a great thing to do. And then also, if we're lucky, we can use the buttons to change effects as well. And what I would normally do in my set is I'd set up different things to load on different presses of events. So you can play different sets or load different images or any of the visuals that you've seen. It's a great way of controlling things. And that's basically it. That's how we make visual software in a browser. But is any of this real? Is it all just fun and games? This is me. So I have a pocket projector. So I put my pocket projector, my MIDI controller, and my laptop all in a bag. And then I hacked the bag so you can actually hold it as like a little tray. And the projector comes out the bottom, and you can actually walk around playing music and projecting onto things. So this is me projecting onto the streets of my city. And I wrote a blog post about this last year, and then people on the internet, because the internet is cool, started coming to me and said, yeah, we're doing something that's similar. Or we're making music software, and we saw what you did, and this is very, very cool. So there's now a group of us that all do this. And we must be real. There's about 5 or 6 of us, and we all either make music software, visual software. There's a guy that controls lights over DMX, which is a lot like MIDI, using JavaScript software that he's written. It's brilliant. We have a GitHub organization, so it has to be real. I mean, that's the flag for douche, real, right? And we all now play gigs, which is insane with JavaScript. We play gigs with JavaScript. So yeah, totally real and bro. Before I leave you, I kind of want to address this, because this is important, right? I think I wrote the function wrong. It's easy to do, isn't it? Things I should have included and I didn't. Duct tape, workarounds, bike shaking, and coffee. Yeah, OK. Obviously, this is held together with duct tape. Everything's held together with duct tape. Ben's on a bike. Ben's on a bike. Yes. This whole function is a workaround. Of course it is. And you wouldn't have noticed, but I am drinking coffee. Most useful talk ever. Thank you very much. I'm Ruth John. You can find me on the internet. The music that you heard, am I still on? The music that you heard was by Kanoa, by the way. You can find her on SoundCloud. Thank you very much.
Thanks, Ruth, for this very, very interesting talk. I guess now everybody wants to know how to do this. Where do we start? Are there tutorials? How can we learn this technique?
I actually get that question a lot. Like, where are all the tutorials to do this? There's no sort of collated place for information for this. We have an open Slack channel which anybody can come and chat to us on. Okay. And you can find that on the URL, which is livejs.network. So you can just click on and join our Slack, and we are happy to talk about it with everybody. But I do feel like there's probably a remit for actually collating the information on all of it, just things about MIDI and things about audio and things like that.
Perfect, thanks. Are there other questions here to ask? Just raise your hand. Here is one question.
What about browser compatibility?
So that's a good one. MIDI is actually only available in Chrome and Opera as it stands. Firefox say it's kind of ready, but they haven't released it, so we need to do some research around that. It's not on Edge's roadmap which is unfortunate. But I think the more that we use it and the more popularity it gains, the more it will come into browser because it supports audio so well. Because we run software that we use locally and anybody else wants to use, I feel like we can sandbox that into a browser-specific thing. I know that a couple of the other people I run Live.js with, they use things like Electron and NW.js, so they wouldn't even run theirs in a browser. I just do mine in a browser because it's easier for me to sort of onboard with. So yeah, it's not the most compatible thing.
In the back here. Ah, okay.
Hi. Where do you get the controller? Could you show it?
Yeah, so this
What's
is
the name?
it's a Minim. This is actually a Kickstarter, and you can actually just buy them online. If you search for MIDI controllers, there is a whole range of them, and you can start quite cheap. And a lot of people do ask me, what should I buy? Think about what you want. If you just want to play, I would recommend like an Akai LPD8 or a NanoPad, both of which are about £30, so probably about €35. And they're really, really good just for onboarding and just playing with the code and just seeing what happens. And they have a number of pads or dials. So they're both quite nice, cheap things to get started with.
In the back here.
Is there any way to cheat? Like get the file to analyze it and find out which frequencies are the strongest before making visualization in the fast way?
Specific frequencies, like detecting specific frequencies?
Yeah, like if I have like this really high-pitched song or if I have like this death metal song, you know.
So I think that's probably why I was doing the workaround analysis, because eventually you'd want your software to get smart. You'd want to be able to do that. You want to be able to go, okay, there's quite a lot of activity in the higher realm of the spectrum. So this is obviously techno or something like that rather than hip hop. So I've got a switcher now in my software which will change so that I can get better visualizations based on the input that I'm getting. But I kind of needed to do that initial work to make sure that I was getting better analysis. But there's nothing within the audio API stuff. It's very, very low level. It's just giving you back that array. Does that help?
Like you get information in real time, like when, like for every second or part of the second when you.
Yeah, you wrap it. You request animation frame your function that's getting it, so you are getting it in real time. But yeah, you're getting whatever it is you're analyzing.
The guy in the blue shirt was first.
Hi. What are the possibilities of audio API now to play multiple sounds in a sync? I used to create, or I tried to create rhythm machine back in the days, but it was going out of sync and it was skipping sounds. So is it fixed now or
That's a
still
really,
buggy?
really good question. The audio API clock is brilliant, but I would still probably recommend a library. Tone.js is pretty good at syncing and playing multiple sounds together because all of that has been abstracted away from you having to do it because it is, can I swear? It's a bitch. And I think it has got better, but I think it's probably got better because the browser and the hardware themselves have got better. Chris Wilson has written an article called The Tale of Two Clocks, which is all about the JavaScript clock and the audio API clocks that use the onboard clock, and how they work together and why everything doesn't sync. I recommend reading that because it is a bit of a mind melt. Read that, then use a library. Yeah. But it should be better, yeah.
Can you distinguish audio channels?
Using the audio API, yeah. There's channel nodes, then there's panner nodes, then there's spatialization. Spatialization's insane. Yeah, there's plenty of ways of doing channel stuff and panning stuff and all that, yeah.
I would say there is time for one last question.
Cool.
Okay, here.
Any wish list for the next generation of the web standards that I can make happen for you?
Audio workers, please. They've been in spec for a long, long time, and they're still not here.
All right, I'm on it.
Thanks. I think we're all on it. I think there's just a case of deciding specifically, because web workers are in spec, and yeah, Chris says that they're here and they've been done. I don't. Yeah, I'm still trying to get my head around web workers, so I think that'd be a really nice way for me to do it if it was an audio API, because I'd understand.
Okay, so please a very warm applause for Ruth.
Thank you.